Alright, welcome back folks. In this video we're going to discuss another example of using ratios to solve proportions. Remember what proportions are, right? Proportions are those comparison of two ratios, right? Or the equality of two ratios, and we're going to use one ratio to find the missing value in another. That's what proportions are. That's what the proportion problems are that we're going to be working with. Let's take a look at another example of a real-life scenario in which we might see proportional logic come into play. And that's the following. A recipe calls for 2 teaspoons of salt and 8 teaspoons of sugar. Now, Jerry is making the recipe on a larger scale for a catering event. This is a fairly common situation. You have a small recipe that you want to make larger. If the larger recipe calls for 16 teaspoons of salt, how many teaspoons of sugar will Jerry need for the recipe? Now, this is a fairly common experience, like I said, right, where you want to scale something up. You want to make it bigger. Or maybe you want to cut it down, right? You want to cut the recipe smaller. Or you want to scale down the model of a car that you're trying to build. Or something, anything. All of these are real-life scenarios. So let's take a look at this. Remember, in order to do proportional equations, proportional problems, what we want to do is set up the ratio for each scenario and equate them to one another. So here, what is the ratio that we're going to be making? Now, it's not explicitly said in the problem. It usually would say like salt to sugar or sugar to salt. In this case, they're giving us some free rein. Okay, so let's set up the ratio of salt to sugar. Okay, we're going to do salt to sugar. Now, the important thing is that even if they don't outline for you which ratio you should be doing, it's important that you keep the ratios the same in each scenario, right? If you're comparing salt to sugar in the first recipe, you should also be comparing salt to sugar in the second recipe. Don't mix them up because it's going to mess things up for us. So, in recipe 1, what is the comparison? So salt is 2 teaspoons, right here, and sugar is 8 teaspoons. So 2 over 8 is our first ratio in recipe 1. In recipe 2, again, if we're looking at salt to sugar, well, we see that the number of teaspoons of salt is 16. So salt is 16 over, now we don't know how much sugar. So what can we use in place of a value we don't know yet? We can use a variable. Let's use the variable x. So now we have 2 over 8 is equal to 16 over x. I have 2 separate ratios that I'm equating to one another. This is a proportion, right? This is proportional problem solving. I need to figure out how 2 over 8 and 16 over x are equivalent to one another. I need to find what x is. And we can do this using cross multiplication, right? Multiply both sides by 8 and multiply both sides by x. When we do so, 2 times x makes, well, 2x. That's equal to 8 times 16, which is 128. So, we have 2x is equal to 128. Now it's a one-step algebra problem. Let's divide both sides by 2. And we get x is equal to 64. X is equal to 64, which means that's how much sugar is needed in the larger recipe. 64 teaspoons of sugar are required for the larger recipe. And we used proportional logic, we used ratios to solve that. Alright guys, thanks a lot. Check back in for more examples. I'll see you next time.